I'm presenting these two feature projects today. One is DLH Park, the other is Varavigna Park corridor. So why still? Since morning you must have heard from so many speakers, durability, flexibility, strength, then it can be easily formed, joined, its strength and weight ratio. It is very good at for doing some flexible forms, and it is recyclable, so it's a green material. So this is, I think every speaker must have talked about this. This is what engineers say. For architects, we are dreamers. And we always look at structural steel as an aesthetical element. So like what Nitin Bhai was explaining, exposed steel. Why exposed steel? Because we want some aesthetics out of it. Most of the time we try to explain our structural engineers what exactly we want. Not all of them can deliver what we exactly want. So now more and more projects, we are actually trying to design our structural steel ourselves and then getting the structural design from the structural engineers. So it's no more hiding. We don't want to hide structural steel anymore. We don't want those encasing because we know paints and vermiculite plastic can always use that paint. So we want always exposed. So far we were achieving normal frames, structures with steel, but then slowly we saw skylights, we saw decorative staircases. Almost every apartment, every duplex apartment, they want some key feature with that structural steel staircase. Then atriums, all mall atriums, we did at least 30-40 malls, all atriums, lightweight structure, either covered with polycarbonate sheets or with tensile fabric. Now the next is facade schemes. Now there are multiple ways you can use steel as a facade scheme. So if you go and do a little bit research, because that is not my today's topic, but you can actually use RoboFold methodology to use structural steel for facade scheme, and you can do innovative design center. These are few projects where we use conventionally, I still call it conventional use of structural steel. My project at Bhopal, a mixed-use project where we have a shopping center, kind of galleria, almost 3 lakh square foot of total floor plate, multiplied by 4 floors, so around 12 lakh square foot of shopping area, with multiple of these atriums covered with tensile fabric and tubular structure. This is my own office at Andheri. We have got this entrance lobby, very decorative, a key feature of that building. The facade is such that everything is projecting out the cantilevers. You can see that cantilever on the view. The central portion is a conical cantilever coming out. So the entrance lobby, the main lobby on the main road, it's a cube which is tilted out to match with the building facade, and something like this. That this whole thing is a cube which is tilted. It's cubed. And these double height escalators, they lead to the main entrance lobby on the first floor, and that leads to our office. So this becomes very prominent key feature, and I think this is one of the best part of that whole building. Then, of course, as I said, every mall you need something to cover the atrium. So a tensile fabric with structural steel, the tubular frames to give that aesthetical feel from inside the atrium. Exactly opposite Borivali station, a whole building, majority in structural steel. These elliptical elements are in structural steel. The skylight from bottom, and very interesting, this structural steel staircase, a key feature of that atrium, with glass steps going into the lower ground from the main atrium. Now, coming to the main key features, these two projects which I want to highlight today. One is DLH Park at Goregaon. This is the building exactly on the SV Road. This is the completed picture. The key features like the topmost portion is an inclined conical shape, a penthouse corporate villa. Then I have got those wind crowns on the top. Then this sky gym, which is at the intermediate level. And there is one very interesting conical curved glass structure that is the main key feature. It is visible from SP Road, and that is on the parking levels. Below that there are double-ended entrance from it, a huge canopy. Now this is almost like 7 lakh square feet structure, but in a single photograph that looks smaller, but it's a huge structure. Now there are methodologies where we actually can do the design structural steel, we can coordinate with the structural engineer, we can give our inputs. There are softwares like Rhino, then Revit. This was done in Revit because done in 2007. So we started using Revit in 2006. This was done in 2007. The form was very peculiar. We started with this tall structure here, 30 story, and because of our FSI constraint, as usual, the height kept on varying. So from 28, 22nd, then 18 stories, and again it came back to 20 floors. So finally, this was the final look, kind of squarish, bulky feel, and the whole structure was done in detail in Revit. So the main key feature, which is that atrium, that was done in Revit, and the whole idea, we tried to explain to our structural engineer. Now, our regular structural engineer, I don't know to name, but our regular structural engineer could not deliver. So we had to hire somebody who was specialist into that. And we got this made. This kaijin is cantilever out, and there are 3 curved structural columns which are supporting those kaijin. And because they are curved in nature, it has got that buckling kind of tendency. So to avoid that buckling tendency, we have got those horizontal purlins. And the structural purlins holding those 3 members there. And this whole structure is covered with spider, articulated spider glazing. So from inside, as I said, those curvilinear members and the curvilinear purlins. This whole structure becomes a 2-sided curved structure. So almost every glass was of different size. And we calculated each and every glass on Revit, and we give the sizes to the fabricator. And looking at the detailing, to avoid that bending, we have got all the joints, pin joints. And now, right now, this is the finished look. Now there is a restaurant, a very interesting interior and very nice restaurant, very good food they serve there. This is the night view. So at the night time, the steel structure, that becomes the key element of the whole decor, interior decor. We don't have anything, no false ceiling, nothing. We just highlight that structure from the lights from below. Again, a daytime view, a natural light comes in and becomes very dramatic. So, going back to the next project, this Vanavigna Park at Kerry Road, 64-story twin towers. Right now, we have converted the project to 61-story, and many of us know this as a controversial project. Somebody asked me today morning, can I buy 2 flats there? I said, certainly you can buy. He said, there are so many controversies. I said, zero controversy. He said, your name was appearing in the newspaper. I said, no controversy. I know it 100%. So, zero controversy project for the time being. And again, the key features, the crowns at the top, penthouses in the front to create that crown, again give that crown, which is the part which is coming out of the basic geometry. There are wind tunnel, we have actually provided windmills there in the 4 wind tunnel holes. If you can see, the whole building becomes a wind scoop kind of this thing, and then the wind passes through it. That reduces the wind pressure, as well as we have the windmills there inside. And then double height interlocking decks. You can see the basic elevation of the building is actually comprised of only double height decks. All functional elements, not a single redundant element into the elevation. And we have got a state garden inside the podium. So we have got a 3-level state valley garden, and we have created the whole landscape. which is exactly at the rear side of the building. And again, we have got a in the front side, which is the black portion, which is not really very cleanly visible, but there is a gym which is exactly on the top of that entrance lobby, and there are two twin columns, mammoth, huge 3-meter diameter twin columns supporting that almost like 11,000 square feet of clubhouse area from bottom. The height of those columns is almost like 23 meters. So 23 meters freestanding columns supporting that 11,000 square feet area. Now here my key feature is that crown at the top. So we had series of explorations, experiments, and we tried to achieve something which was unique. The first idea was this. I discussed with my client, and we finalized on this. We'll have a tensile fabric on the top. We'll give lighting from below, and it will have dramatic effect. And the whole curved tensile fabric, it will match with the curved facade of the building. And we presented this building in multiple places. We got multiple awards for that. We have received almost like 32 awards for this building so far. And the first award we got was Asia Pacific Bloomberg Award. And after that, this was the tensile fabric. We did it in Revit, and these are three options we tried in tensile fabric. Then my client's son came into picture, and he said, okay, this is not timeless. So to understand the definition of timeless, it took me almost like a lot of time, 3-4 months. And in that time, I tried to make again a timeless structure where we tried to make this whole space frame on the top, a new idea, whole space frame on the top with LED lights, kind of media mesh, so that when I control them, it will create some kind of wave, a movement of wave, and it will be visible from bottom. Because it is a freestanding structure, that structure will cover the service cores, the lift machine rooms, and we had photovoltaic cells glass covering randomly placed on that steel structure. So something like this. So to create this form, again, I used Grasshopper, Rhino, algorithmic softwares to generate the form, and we discussed this with various consultants, and it is clearly visible that Avigna is written there, but that written are actually the panels, and it is not going to be visible from anywhere unless somebody looks at it from top, helicopter ride. But then it is still visible. Maybe A is visible, AB is visible, and on the other side it is NA, yeah, that is visible. So somebody will have to grasp or imagine that something is written there, and it was kind of indirect hint I wanted to give. Finally, again, after a few years, time passed, we got few more awards, and then eventually the client got bored with the idea. He said, no, now we want something else. So I said, this time you don't suggest, I'll try something else. And then I came up with this idea. I tried to design one steel cage structure made up of tubular steel, and then we'll have kind of thick plantation inside, so that if you light those plantation, that is the crowning feature of your building. And then to clean or to maintain the building, we designed those BMU cranes on the top. They are visible in all the options. So we made these 3-4 options. Again, geometry was a little difficult. It was kind of two-sided curve. It was curved in horizontal plane, as well as I wanted those sides to be little curvy. And to achieve that, and then again the height was something which was becoming really very tricky. We were playing with those height in the permissible limits of civil aviation, and that height was not being finalized that easily. So every time my client used to tell me, now you have got so many meters of height. Then he said, no, now we have to reduce it. You can only have 9 meters of total height. So we kept on changing that, but thanks to again this parametric algorithmic software, and we achieved that every time he used to change, it was just a click and we used to do the new iteration. So something like this. And this was kind of final fill. Now, again, we have, I think, structural engineer Mahindra here. I think he's either in the adjustment. He is our structural engineer in this building. So, again, the idea has changed. But I will not display that idea because it doesn't have skill. And I'm sure, I'm really very sure that I'll force my client to accept this finally, because all the awards, all the big awards we got with this idea. So I told him, if we change this idea, you'll have to surrender all those awards. This is the final look and feel of it. There is some, I think there is some problem with the font. This just concluding. This is what I feel. Skill structures, they give a feeling of rationality, because actually a viewer can imagine, he can grasp the forces. He knows horizontal member passing force to vertical member. It is visible. In RCC, it is hardly visible. And still, actually, a person can indirectly get the idea, grasp the idea of the forces. And it is very logical. It doesn't give that feeling of redundancy, even if it is redundant, because we don't provide those purlins if we don't require. We don't provide detailing which is not required. So every detailing, every time member, every detailing is actually functional and it is required. So it gives that feeling. And whenever we use it, compose it, like you explained in your presentation, whenever we use it with conventional technologies, conventional construction methods, it creates that contrast and gives you a very interesting key feature. So, skill structures are aesthetically appealing.